today's video, we're going to talk about using the Calibre toolset to do design rule checking, DRC. And before we begin, we need to make sure that we have the Calibre tool loaded into our environment. In order to make sure that we have it loaded into our environment, we have a script that we need to add to the .cds init file that we use in our with our associated PDK. In this case, we're looking at a 65 nanometer kit from TSMC. Looking at my home directory and navigating to my work path for this particular process, we're going to open that CDS init file, scroll down to the bottom, and see that I've added some text that launches the Cadence environment, the Calibre environment, and includes it in the Cadence environment. Now, for those of you that are at the University of Utah and have access to my personal directories, you can, of course, just copy this setup and it should work for you. After you launch Cadence, if that init file worked properly, there should be a Calibre drop-down menu at the top of your layout. Here I've created a layout and a schematic. The layout should ideally mimic the schematic, and we'll find out about that with another tool called LVS. But let's first look at DRC, Design Rule Check. So I've clicked Run DRC, and I already have a run set saved, so I'm going to open that run set. And what I've saved were changes to the location of the rules file. So here you can see the rules file is at this path. And I've changed the run directory. I've made a directory under my TSMC directory called Calibre Runs. And the reason I do this is that I want to pipe all the output files into a separate directory so that I don't clutter my normal work directory for this particular process. Inputs and outputs should be set automatically based on the schematic associated with the layout and the layout itself. And then the outputs, of course, are just going to be report files. Under Run Control, you might select Run Calibre in a multi-threaded fashion to speed it up, especially if you have a very large design. Once all of these are set, we can run DRC. And it's going to ask us if we want to overwrite some files that I've already written. I've already run DRC on this particular file. Once the DRC is complete, an RVE tool will open automatically. If it doesn't, you can click on Start RVE. And this is going to help us to debug our design to figure out where we've made violations. Now, some of these errors that occur we can ignore, and some of them we can't. Anything that has a .dn, for instance, is a density error, and we don't need to worry about density at the cell level. We need to worry about it at the full chip level. So this is just a cell. We'll worry about density later on. But you can see here that there is a spacing error, M1.S. So there's some spacing error associated with metal 1. And we can zoom to that spacing error by clicking on the error itself. You can see that the layout tool zoomed to the error. It's difficult to see because we have a lot of metal layers visible, so I'm going to just select the M1 metal layer and make everything else invisible. Okay, you can see this spacing error. It tells me that the metal line width greater than 1.5 and parallel metal line width greater than 1.5 needs to have a spacing greater than 0.5 microns. So I would have to move this object so that the space between this object and this object was greater than 0.5 microns. You can see right now that it's at 0.49. So very close. I just need to move it over a little bit and I would get rid of that error. Now you can see that there are a few other spacing errors and whatnot, and you can kind of figure out what these errors are as you move through the kit. You can see here this is probably a width error, VO1, so it's a width error associated with VO1. If I enable VO1, now I can see that I put down some vias that ended up overlapping, and that's causing these errors, so I'd have to figure out a way to make the vias not overlap. Okay, well, you can see the basic procedure for running the tool and also how to interpret the results of the tool from this. In the next video, we are going to look at the layout versus schematic, or LVS tool. So we will see you next time.